we can all float in water, but have you ever wondered why? I mean, water is so much denser than our bodies, so why don't we sink? Well, it turns out that the reason we can float has everything to do with the way that water moves around. You know, like this magic floating ball? What makes it float isn't what you think. Hi, it's me, and this is my channel. The reason this ball floats isn't because it's made of a special anti-gravity material or anything like that. Instead, it has a really slick surface, which means that the water slides off of it really easily. But why does that make it float? Well, it's all about how fast the water can move around. You see, water has a unique property. It's really good at transferring momentum from one place to another. Now, normally, when an object moves through water, like if I take this marble and drop it into the water, it disturbs the water and the water pushes back on the marble, slowing it down. That's just Newton's third law of motion. For every action, there is an equal and opposite reaction. So the faster the marble moves, the more water it disturbs and the more it slows down. But here's the thing, water is really good at passing on momentum, which means that it can quickly get the water moving around it really fast. And when that happens, water can actually do something really weird called turbulence. You probably experienced this sometimes when you swim in a pool and suddenly your arms and legs start flailing everywhere. You might even be doing the correct stroke, but no matter what you do, you just can't seem to get a good rhythm going. Like you're fighting some kind of underwater current. That's because swimming pools have a lot of stuff in them that can disturb the flow of the water. Like the walls of the pool itself, the ladders and stairs, even the other swimmers can all disturb the flow of the water and make it hard to swim. And in a wild pool, that turbulent water can move in all different directions and slow you down no matter what stroke you were using. But what if you could find a way to move the water around you perfectly? Then you would unexperience any drag from the water at all, and you would be able to swim infinitely fast without getting tired. And that's kind of what's happening with this magic floating ball. Its surface is so slippery that it allows the water to move around it really fast without any turbulence. And when the water moves really fast around an object, it actually creates an area of low pressure. So when the water around this ball moves really fast, it creates a low pressure environment below the ball and a high pressure environment above the ball. And that difference in pressure pushes the ball upwards, allowing it to float. Here, you can see it more clearly. The fast-moving water on the bottom creates a low-pressure environment, which pushes upwards on the ball. That low-pressure environment below the ball and the higher-pressure environment above the ball creates a net force pointing upwards, which makes the ball float. This effect is so powerful that if you could make a sphere of this material, it would float in water without touching the bottom or the sides. But unfortunately, it turns out that making a perfect sphere is really difficult. So they usually have to settle for a really smooth sphere that still allows the water to move around it really fast. Now, water isn't the only liquid that can do this. Any liquid that transfers momentum really well, like mercury, can also create this floating effect. In fact, when you spill a cup of water on the ground, the water doesn't just fall straight down. It kind of slows down near the end. And that is because the water on the bottom of the cup is moving really fast towards the edge of the cup, and that fast-moving water creates an area of low pressure below the water on the top, which pushes the water up and slows it down as it falls. So next time you pour a cup of water, look closely and you'll see that the water doesn't fall straight down. Instead, it slows down near the end because the fast-moving water on the bottom of the cup creates an area of low pressure below the water on the top, which pushes the water up and slows it down as it falls. Okay? Well, what about us? Can we use this same trick to float in water? Well, it turns out that we can. When you jump into a pool, you probably notice that you can stay underwater for a few seconds before needing to come up for air. But when you come up out of the water, you might notice something strange. Your mouth is full of water, but your nose is completely dry. That's because the water can sense that there is a fast-moving area of low pressure above your head, and it rushes up your nose to try to equalize the pressure. So the water can rush up your nose because it's less dense than your body, just like this magic floating ball. Because we are less dense than water, we can all float for a few seconds underwater. But the water can sense that there is a fast-moving area of low pressure above our head, and it rushes up our nose to try to equalize the pressure.